Howdy, rock buddies. It's Rock Papa. Today we're going to do something a little bit different from identifying rocks, but it's similar. We're going to pretend that we are Superman or Supergirl, super person. And if you were a super person, you could drill straight down into the earth to get to the bowels of the earth. When you got down to about 30 miles, 25, 30 miles, you would hit the mantle. So we're going to talk about the mantle. The mantle is a plasticky, molten mass of rock. And it's the most abundant rock on planet Earth. So we're going to look at what the mantle is made out of and what happens to it when the mantle gets shoved up onto the land. Okay, let's say we made it down to the mantle, and what were we going to find? We're going to find this rock, Peridotite. It just looks like a grayish rock. It's very heavy. Peridotite is made of olivine and pyroxene, and it has a cousin. If there's more olivine than pyroxene, we call it Dunite. Both Dunite and Peridotite are made of olivine and pyroxene, maybe some additional minor minerals in there. Down in the mantle, the Peridotite and Dunite they may be solid, but they're plastic because they're under such huge amounts of pressure. This example of Peridotite obviously has more pyroxene, which is a black, dark mineral, than olivine, which is a greenish mineral. And this came from a major fault in the mountains of North Georgia. Peridotite / Dunite and all of its metamorphic products, which we're going to look at pretty soon, are called ultramafic rocks because they are so full of iron and magnesium, but have virtually no quartz at all in them. The higher the quartz content, the more a rock is considered to be felsic in its composition or reaction. So these are ultramafic rocks. So how does this Peridotite / Dunite get up on land, and what happens to it when it gets up there? Well, when continents collide, one continent acts like a giant bulldozer and digs way down deep into the mantle and scrapes some of that Peridotite / Dunite up and shoves it up on land along with a big pile of ocean crust. That's a continental collision situation. If you have subduction, the same thing can happen. The subducting ocean crust that goes down below the land, or another piece of ocean crust, can slough off not only ocean crust but also some of the mantle with it, which is just below the ocean crust. So what happens when Peridotite / Dunite, the main rock of the mantle, the most abundant rock on planet Earth, gets shoved up on land in a tectonic event? Well, down there where Peridotite Dunite lives in the mantle, the pressure is unbelievably enormous on it, and the temperature is unbelievably hot as well. But when it gets shoved up onto land, both the temperature and the pressure take a huge plunge downward, and that changes the conditions that Peridotite can exist in, so it morphs. And what does it morph into? It morphs into several rocks, one of them being the state rock of California, and we're going to look at those rocks in just a second. So you guys may be wondering, Papa, if this is Peridotite from down in the mantle, Why is it still peridotite even though it's been shoved up on land? That is a fantastic question, and it shows your thinking. My conclusions are that down in the mantle, peridotite may look a little different from this rock, and also that once it's shoved up on land, peridotite/dunite undergoes its metamorphism into other rocks very slowly, and this hunk is still in the process of changing. I could be wrong, but that makes sense to me. Hopefully it'll make sense to you too. Take a look at this stuff. What general color do you see here? Greenish? Yeah. Let's look at this guy. Greenish, yes. This is serpentinite. And they call it serpentinite because someone thought that those little mineral crystals in there that were kind of greenish looked like snake skin. Here's some more serpentinite, and we also have soapstone. You've heard of soapstone. Welders use soapstone markers to mark their weld because soapstone, serpentinite, and peridotite have extremely high melting points, so the heat of the torch won't melt them. Here's another sample of serpentinite. Characteristics of serpentinite are that it's greenish in color, and the main thing is it's soft. See how my thumbnail can scratch it? Serpentinite and soapstone are very soft. Native Americans used to take serpentinite and soapstone, since it's so easy to carve, and they carve objects. They would carve off bowl shapes and carve them into bowls. They would also make flat griddles over their fire, and those griddles would get very hot, but they wouldn't in the fire, but they wouldn't melt or crack or pop because peridotite, soapstone, and serpentinite have very high melting points, the highest melting points other than quartz. Look at this guy. This is a hunk of asbestos. It's also a rock associated with the serpentinite and soapstone. As you know, they use asbestos in brake shoes for vehicles because it has a super high melting point. But as you also know, asbestos fibers can cause lung cancer. And all of these products, all of these rocks, asbestos, soapstone, and serpentinite, have that same, the dust from them is carcinogenic. So that's why I'm holding my breath right now. Talk pretty good when I'm holding my breath. Okay, rock buds, that's it for now. We've talked about the mantle, and the next rock video is going to talk about what's just above the mantle and what it is made of and how it gets shoved up on land as well. So thanks so much for watching. Have a great day and happy rock hunting. Pop out.